bias circuit. Now, in emitter feedback bias circuits, you have RC, you have power supply VCC, and then you have one resistance RB, and यहाँ पर emitter, in emitter you have one more resistor, which is called RE. So you have RC, you have RB, and you have RE. Okay, this is the input side, and this is your output side. Okay, and here I'm putting the sign, current sign, common emitter, NPN transistor. Now, rest is everything same. Analysis is same. Okay, only circuit we have put one resistor here. Now there is something, some quantity will change. Like if I want to calculate the IB from the input circuit, so then what I write? I write minus VCC plus here the current is IB because IB is going. So the current IB flowing here, current IC flowing in the RC, and IE is flowing here. Okay, and I we also know we can put I equals to beta plus 1 IB. Okay, and you have to understand also that IB is negligible. So if I want, I can put I equal to beta IB. For accurate, you can write like this also, and then you have to remember that your IC is almost equal to IE. So now let us calculate what we want to write. The input loop minus VCC plus IB RB, and now here you have a VB, so plus VB should be always forward bias. Okay, it should be forward bias. Is a P and P transistor, then should be minus, should be plus. Value is same. Okay, and now minus VCC IB RB, here VB, and then you have IERE, which I want to write in terms of beta. So I can write beta plus 1 RI IB equals to 0. I hope this is clear to you. IERE, I'm writing beta plus 1 IB RE. Okay, now you can calculate the value of IB from this equation. So IB will be your VCC minus VB, okay, RB plus beta plus 1 RE. If you want, you can write it as a beta RE also, because 1 is negligible. So whenever you can neglect 1 also, so it will not change the accuracy. It will not affect the accuracy much. So this is the input equation. Output equation is same. Output equation, what is output equation? IC will be your beta IB. So beta, now again VCC minus VB, again beta plus 1 RE RB, and VCE. Now you want to calculate IC saturation. So first you have to write VCE. VC is what? VC now in this loop, I'll write minus VCC plus ICR plus ICRC plus this VCE plus IERE plus IERE equals to 0. Now IC and RE are almost same. Okay, so I can write here ICRE. So I can write minus VCC, okay, RC plus RE, this RC plus this RE, and I'm taking common IC. I'm putting IC equal to IE, this one here, and plus VC equals to 0. So my VC will become VCC minus IC RC plus RE. Okay. So from here, if I know the IC value, I can calculate the VCE. So you know the operating point. Now, what about the IC saturation this time? IC saturation, बताओ क्या होगा? What is the formula for IC saturation?
VCC upon RB.
RB?
RC, sorry.
RC. So how to calculate IC saturation? For IC saturation, you should remember this diagram. For IC saturation, what is the value of VCE? 0. Then put the VC 0 here. Always short circuit this one. If VC is 0 here, then your IC will be VCC upon now RC plus RE for this circuit. Earlier circuit, this RE was not there. Okay. Now difference between this circuit and earlier circuit is there. Now here this point is your VC. This terminal is your VC. This terminal is your voltage here is VE. Ammeter terminal. It's a collector terminal, ammeter terminal. This difference is VCE. Earlier, what was there? Earlier, this resistance was not there. V was 0. So if I want to write VCE, that is VC minus VE. Earlier V was 0, so VC was equal to VC, but not now. Now your VC and VC are different. Okay, that point you have to keep in mind in this circuit. VC, and how to calculate VC, tell me. VC you can find from this equation. If you want to find VC, how do you calculate VC? Tell me. How to calculate VC? So VC is basically VC is equal to VCC minus
IC into RC plus RE.
No. अरे भाई इस पॉइंट का पोटेंशियल क्या होगा? ये पोटेंशियल ड्रॉप, ये पोटेंशियल बचा हुआ यहाँ पे आ जाएगा. VC not VCE. VCE तो ये रहा. Only if I want VCE, this minus VCC, this drop, this KVL, I can find the VCE now from this equation VCE. But if I want only VC, this point voltage, then I can find VCC minus ICRC. Similarly, if I want to calculate VE, this is IERE, or approximately ICRE. This is your VE. Now VC minus VCE again will come this equation. If you do minus, again you will get same equation. You do it minus VCC minus ICRC minus ICRE, again the same equation will come. So this point should be clear. Is there any doubt? VC is basically VC minus VE. You put the value VC here, put the value VE here, you again get this equation. Now this is simple thing you should understand. Na? This voltage drop remain this way. This is voltage, okay, and this total drop VC. This is VE. This point voltage. This is the base. Here potential is VB. If I want to find VB, how to write VB? Tell me. Potential at base. What is VB?
Sir, VCC minus RB, IB.
Yes, VCC minus IB, RB. ये potential drop here, remaining comes here. So these small things you should know. Okay, otherwise you will do mistakes in the exam. So let us do one problem based on this circuit. Now analysis is same, only little bits of quantities have changed. Okay, so I'm giving you some value. You tell me the operating point and region of operation. I'm rubbing this one. Okay. If no reply is coming, I'm going to rub. Then you don't tell that I will not return. So the next is, let's say I'm giving some values. say RB is, VCC is say 6 volt. VCC is 6 volt. RB is your 10 kilo ohm. And then you have RE is 100 ohm. 100 ohm. And then VBE, because this tungsten is made of germanium, so I'm taking 0.3 volt. Okay, and I'm taking RC value as 75 ohm. Okay, find the operating point and operation region. So first of all, you have to find what? Now you calculate all the things. Find operating point. Find operating point, operation region, and then you find VC also, you find VB also. All the points you have to calculate.
So what will be the value of beta here?
Beta value is given 50. Beta is 50. So let us calculate now. IB, IB will be VCC 6 minus 0.3. Okay, and then RB is your 100 kilo ohm plus beta plus 151 into RE. RE is how much? RE is 100 ohm. This is 6 minus, this is 5.7. 100 kilo ohm plus this is what, 5 kilo ohm. So 5.1 kilo ohm. Okay, calculation you do and you tell me what is the value of IB.
So 0.38 milliampere.
0.038. 0.038 or 0.38. Okay, I don't know.
0.38, sir.
Okay. Okay, and then you want IC. IC is your beta 50 into 0.38 milliampere.
So 19 milliampere आ रहा है.
19.
IC.
IC is 18.5 or 19? 19. Okay, I'll put 19. Please others student also check. I don't have exact values. 19 milliampere. And then you will find the VC in IC saturation. IC saturation is VCC 6 upon RC plus RE, 175 ohm. How much is coming? Tell me. 34 milliampere. Okay, 34.28 milliampere. Now you can compare. So IC is less than IC saturation. So this is operation point is active. Operation point is active. And now you have to find the VCE. What is VCE? VC is your VCC 6 minus IC 19 milliampere into RC plus RE 100 plus 50, 100 plus 75, 75, 175, 175 milliampere. Okay, tell me what is coming VC. Around 2 point something, 2.6, how much? Karishma? 2.8, 2.8 volt. Okay. And now remaining VC and VB, you can find out. I already told you the formula. You can calculate later. Okay. Let me do one more problem. Same circuit. Same questions, same quantity you have to calculate. Your VCC is now 15 volt. Okay. RB is your 100 kilo ohm. VB is your 0.7 volt. And then your RE is your 100 ohm. RC is 900 ohm. Okay. Now you calculate quickly. Beta value is 100. Beta value is 100. So again, IB VCC minus VCC is now 15 minus 0.7, then 14.3 volt divided by RB. RB is 100 kilo ohm plus beta plus 1, 101 into RE. RE is 100. So this comes 14 by 3, 100 kilo ohm plus 10 kilo ohm. 1000, correct? 10.1 and 1000. Okay, 10.1, 100. So 101.1 kilo ohm. So tell me in the value of IB, 0.129 milliampere. I have this. You can tell me what is exact. कितना आ रहा है? 0.113 आ रहा है कि 1.29 आ रहा है? ऑलमोस्ट 0.13. करिश्मा कितना आ रहा है? 14.3 divided by 1110.
0.12 milliampere.
12. Okay. So I will write this is almost equal to 0.13 milliampere. So IC will be 0.13 into 100, that is 13 milliampere. IC saturation, that will be your VCC, VCC upon RC plus RE. RC is your, this become so 100 plus 900 plus 900 plus 100,000. So this is 15 milliampere. Okay. So IC is less than IC saturation. So the operation region is active. And now you will find BCE. VC is equal to your 15 minus IC is 13 milliampere, 13 milliampere into RC plus RE is 1000. This cancels out, so VC comes out 2 volt. So VC is 2 volt. This is your operating point. 2 and 13 milliampere, 2 volt. Operating point Q, 2 volt and 13 milliampere. And remaining quantity VC you can find. VC and BB calculate. So this was your ammeter feedback bias circuit. Okay, up what is the next? Next is the most important biasing, which is practical. Okay, which does not have an effect of beta much. Okay, this you can say it is almost beta independent circuit. So that circuit we will discuss here. Also, it is still we have beta dependence. Now, if you change the beta value in this same question, I'm telling you, if you change the beta value, you can find how current varies. Okay. So this circuit, if you increase the beta, it will go to IC saturation. So don't do for this question. First question, you make it beta twice data and you check how IC is varying. So let us now see the next circuit, voltage divider bias, which is the most important circuit. Most your exam questions basically comes on voltage divider bias. So I'm rubbing this one. Voltage divider bias. And this is very important. Now, voltage divider bias can be done in two ways. This board is not coming clearly. Why? Just give me 1 minute. Huh? Is visible ना board but become black. Okay, बाद में अभी काम चला रहा उसको बाद में सेटिंग करेंगे इसकी. Okay. So voltage divider bias. So there's two methods. One is called approximation method. Approximation method. And second is your exact method, exact calculation, exact method. Now, what is voltage divider bias? Voltage divider bias means you have circuit, you have VCC, you have a RC, and along with RC here you have a voltage divider. You have two resistance, R1, R2, and here you have RE. And this is your ground. and here you have a power supply VCC. So first I'm going to discuss approximation method. Now it is very easy method, and you will see this method does not have a beta dependence. Suppose beta value is also given. So this method you can apply this approximation method. Its values will be only approximately, but it will be always close to the actual values. Okay, but if you do some if you do some you care some properties or some quantities. So, but you can apply this method always. Approximation will always come. Accuracy will increase. So whenever you apply this method, you have to check that this R2 value, this R2 resistance, this 10 R2 should be greater than your beta RE. Whatever resistance here, multiply by beta, this beta RE, this 10 times of this R2 should be greater than beta RE. If this condition satisfies condition, then this method is almost equal to accurate method. The error will be less. Otherwise, error will be high if this condition is not satisfied. So this is a condition for approximation method. Now, what does this method says? Here, current is coming IB. Here, current is coming IE. So obviously, some current is coming, I is coming here. IB will go. Some current will go here. Okay, but this method says neglect IB. Approximation say neglect IB. This is IB is 0 because why IB is 0? Just let me check the whether I'm writing opposite. No, I'm writing opposite. Beta RE should be greater than 10 R2. Beta RE should be greater than equal to 10 R2. Opposite I'm writing. Okay. Now you understand. If this beta RE is greater than, because always here IB will come, IB beta RE will come. We always write na beta RE into IB. Now if this drop is more, okay, if this drop is more compared to this drop, so we can say if beta RE is higher than this NR2, so we'll say the IB coming here is almost less than the what current is going here. Okay, so from here when current is coming, if this condition is satisfied, we assume all the current is going here, because of this resistance, beta RE resistance, this current coming here will be very negligible. First, here is a drop of 0.7 volt. This resistance plus 0.7 volt resistance plus resistance beta RE is compared to higher than this one. So this is only R2, and I'm writing 10 R2. That means this is greater than the 10 R2, this actual resistance. So IB here coming is negligible. So here current will go more. Whatever current coming here to divide here current will go more compared to this resistance. So we can neglect that current. We say IB is not flowing. So now, if IB is not flowing, then what we can do? So I can say now if IB is 0, all the current is coming here. Here no current is going. Now the things become very simple. This point now I know what is VB. Now how can I find the VB? VB I can directly find by voltage division. Now my circuit become like this. This is my R1 and this is my R2. No current is going here. This point is VB. This is R1. This is R2. This is ground. And this is your plus VCC. So I can find the VB. Tell me what is the value of VB? What is the value of VB? Tell me.
Sir, IR1.
I R2 R1 का जाएगा ये है ना VB. This is voltage division ना. VCC gets divided in R1 by R2. This is the current into I into R2. This is your VB. ये पॉइंट क्या होता है? ये माइनस ये होता है ये पॉइंट, और ये वोल्टेज होता है VB from here to here. Okay, Is that point clear to everyone? Now you know VP. Now you know everything. You don't have to do any calculation. Okay. Deepak, Leo, is that point clear?
Sir, can you explain again,
Yes,
sir?
sir, get it.
So, so for approximation method, whenever this kind of circuit is there, you can neglect IB if this condition is satisfied. Beta RE, just suppose 100 RE is, if 100 RE is greater than, suppose this is 1 kilo ohm, 10 kilo ohm. So okay, whatever calculation, whatever values are there, if this condition is satisfied, okay, then you can take IB 0. Once IB is not 0, IB is 0, that means no current is going, then the current is going here, directly going here. Okay, so now you can apply voltage division. This point will be VCC upon R1 plus R2 total resistance is become current, and current into R2 become VB. Now once you know the VB, you know the VBE. VBE value is given. VBE, this value is given. VBE. So VB is your VB minus VE. Okay, this base minus this terminal. This terminal is VE. This terminal is VC. Now you know the VB here, and this VB also you know VB 0.7 will given. So directly you can find this voltage minus this voltage, will give you VE. So you can calculate VE directly without knowing IB, without knowing beta. Okay, you don't require beta, but it's given. So comparison you require, otherwise you don't require beta. So whenever beta is not given, you can use this method. So you can find VE. VE will be now what? VB minus VBE. Directly you find VE. Now you can find, once you know the VE, you can find what is IE flowing here. VE what? VE is equal, IE equals to VE by RE. Okay, so now you know the IE. You don't require beta here. Okay, and similarly, if you know IE, you know IC. So circuit is solved. Now, if you want VCE, so IC you know, VCE, VCE will be how? Tell me VCE, how to calculate VCE? VCE the same circuit. Same circuit is means VCC minus IC RC plus RE, like we have done earlier. First case, ammeter feedback, same circuit. Now VCC you know, IC you know, but directly RC RE will be given. You can find the VCE, or you can find VC like this also. VC minus VE. Okay, VE already you know. VC you can calculate. VC, how do you find? VC is your VCC minus IC RC. Then it is your whatever way you want, you can calculate. IC saturation formula is same. IC saturation formula, because output circuit is same. VCC upon RC plus RE. So this, without solving, writing any KVL in the input, directly you can solve, and this will give almost accurate value. Okay, if this condition is satisfied, this method is applicable almost in every condition. Okay, so that is, so calculation. So things become very simple. You can quickly calculate, solve this circuit, this kind of circuit, if you use the approximation method. Now, if you have a doubt, please ask me. Leo, is it clear now?
Yes, sir. Clear, sir. Now.
Because
Sir, last equation VCE equal to VC minus VE.
yes,
ये समझ में नहीं आ रहा.
अरे भाई ये ड्रॉप कितना होगा इस तक, ये टर्मिनल के बीच में तो VC यही तो होता है. व्हाट इज VC?
सर वो तो ठीक है.
हाँ, ये VC, ये
हाँ.
टर्मिनल VE, इन दोनों का इनका डिफरेंस तो VCE होता है.
हाँ वो ठीक है, लेकिन VE जो हमने लिखा है, मतलब वो इक्वल टू IC इंटू RC प्लस RE.
VE तो ये रहा, this is VE.
हाँ.
So VE is VE, and this is what? This is what? 0.
This is
ground.
0 ground.
So
Yes.
VE minus 0 equal to what? IE RE, this drop.
IE RE.
So that same thing I'm writing now. IE RE. So VE is equal to IE RE. So from you can find IE as IE directly here. And I'm saying that IE is almost equal to IC. IE is equal to what? IC plus IB. And IB is microampere, this is milliampere, so this is, we can neglect this one. So I can write here V equal to ICRE also.
सर
So you can
एक्चुअली मुझे वो कंफ्यूजन नहीं हो रहा है, ये मतलब आईसी ब्रैकेट में ये जो लिखा है ना आईसी आरसी प्लस आरई,
हाँ,
ये
ये वाला।
टर्म, हाँ ये वाला, ये टर्म को हमने क्या वीई लिखा है?
अरे भाई ये तो पहले पिछले क्वेश्चन में निकाला था ना. In last question what we did, if you want to do, you apply KVL here, minus VCC plus current is here ICRC, okay, then plus VCE, then plus IERE. Is that okay?
Yes.
So this I can write IC.
IC, right.
So IC so I can write now VCE is equal to VCC minus IC common and RC plus RE.
हाँ अब सर इसको ये जो सेकंड टर्म है आईसी आईसी ब्रैकेट में आरसी प्लस आरई, ये एंटायर टर्म को हम वीई लिख रहे हैं.
वी क्यों लिखेंगे इसको? ये वी क्यों लिखेंगे हम लोग? वी का नहीं, वी तो आ रही है, आईसी आ रही है.
ओके वो तो सेकंड इक्वेशन दूसरा था. ओके
हाँ वो ये अलग है, ये तो अलग है ना, ये तो वीसीई है, ये तो वीसीसी है ना.
हाँ
वीसी थोड़ी है ये. ओके, अब इसको कैसे लिख सकते हैं? अब मैं इसको लिखूं VCC माइनस ICRC माइनस ICRE. ओके, ना ये क्या है? VCC माइनस ICRC, VCC माइनस ICRC, ये क्या आ जाएगा?
VC, राइट.
VC, और ये क्या है? ICRE.
ओके आई गॉट इट सर. अभी ठीक है.
V.
ओके गॉट इट.
Okay.
ओके
So let us solve some problems. I am rubbing this one. Is there any student, because it's very important? If someone is out, please ask me. Karishma, Siali, Shikhar.
Yes, sir, got it.
Yes, sir, got it. It's very important, sir, because now all the problems mainly I will do on this circuit only. Applications, AC analysis, everything. So you have a voltage divider circuit, RC, VCC, R1, R2, R1, R2, okay, and here you have a RE. Then value is given 100 ohm. R1 is given 100 ohm. R1 is given 100 ohm. R2 is given 2.2 kilo ohm. Okay. RC is given 3.6 kilo ohm. RE is given 1 kilo ohm. Beta is given 150. 150. Beta actually we don't require. 150. Okay. The VB is 0.7. VB is 0.7 volt. Okay. So now first you can check the condition for this circuit. Okay. Beta RE should be greater than equal to 10 R2. Whether this condition is satisfied or not, RE value is given 1 kilo ohm and this beta is 150, so this becomes 150 kilo ohm. Okay, and now this should be equal to, and R2 is what? R2 is 2.2 kilo ohm and multiply by 10, 22 kilo ohm. So this condition is satisfied. If it is even not satisfied, still you can do it. Okay, but the accuracy will not be that good. And now condition satisfied, now you can directly solve the circuit. Solve circuit means first you find the VB. So VB is what? VB is your VCC upon R1 plus R2. VCC, what value I given? VCC value is say 10 volt. VCC is 10 volt. R1 is 100 ohm plus This is your 22. R2 is 2.2 kilo ohm. That is 2200 ohm. Okay. So this becomes 10 upon 2300 ohm. Tell me what is the value of VB? Okay, just 1 minute. 1 minute. And this R1 you take 10 kilo ohm. 10 kilo ohm. This you take 10 kilo ohm. Okay, not that much. 10 kilo ohm means now it will change everything. So this is 10 kilo ohm plus 2.2 kilo ohm. So you take 10 by 12.2 kilo ohm. Now you tell me the value. What is
सर सर इसके साथ R2 मल्टीप्लाई नहीं होना
मल्टीप्लाई होगा? R2 कितना है?
सर 2.2 किलो ओम
2.2 kilo ohm and 2.2 kilo ohm. So this cancels out. Okay. So this how much is it? 22 upon 12.2 VB. How much is coming?
Sir, 1.8 volt.
Yes, 1.801 or 1.8 volt. Very good. Now everything is solved. Once you know the VB, you can find PE. PE कितना आएगा? ये वाला potential. ये वाला potential. This is the drop. So VB minus VBE, that is 1.801 minus 0.7. कितना आ जाएगा? 1.1. So if you put 0.80, you can remove 1 and 0.7. This is 1.1 volt. V. Now once you know the VE, you can find IE. IE will be VE upon RE. 1.1 volt divided by RE is how much? 1 kilo ohm. So this becomes 1.1 milliampere, which is equal to IC. So I know IC now. You can find IC saturation. VCC 10 upon RC plus RE. RC is 3.6 kilo ohm plus RE is 1 kilo ohm. 10 upon how much? 1 kilo ohm, 4.6 kilo ohm. How much is coming? IC saturation?
2.17 milliamp.
How much? 2.15 milliampere. So you can say that this IC saturation is greater than IC. The operation region is active. Okay. And now you can find a VCE. VC is your VCC minus IC plus RC plus RE. 10 minus IC is your 1.1 milliamps. RC is 3.6, 4.6 into 4.6 kilo ohm. This cancels out. Now tell me how much is coming.
4.94.
4.94, very good. 4.94 volt. 4.94 volt. Okay. Now if you want, you can find, you have already VE. You already know VE, you can find the VC, VC, and you can the difference. That is the same thing. Okay. If you find the VC, VC will be how much? VCC 10 minus ICRC. IC is your 1.1 into RC is your 3.6. So kilo and milliampere cancelled out. So this, if you do like this also, something will come. How much will come? 10 minus 1.1 into 3.6, how much will come? Tell me. I'm calculating VC. कितना आएगा? Ten minus 3.6. So almost 6 volt. Almost 6 volt will come. You can check it. And then you have V
6.04.
6.0.
6.04.
Okay. And what is VE? We have calculated just now. 1.1 kilo ohm, 1.1 volt. Okay. You can calculate VCE. 6 minus 1.1, again same thing will come. And similarly, you can find now VB value. Always put the habit, calculate all the quantities. So VB will be your VCC minus, now this time will be I into R1. VB already we have calculated, so not required. VB it's approach VB we have already calculated. Now let us do one more problem which came in your exam. Same, this voltage divider circuit is given, but this time R1, R2 value is not given. Okay. And what is given? This is given. RC is given 2.5 kilo ohm. This is given 2.5 kilo ohm. And RE is given 0.5 kilo ohm. Okay, this is given. And beta value is given 50. And IC value is given. IC value is given 1 milliampere. And they're asking what is the ratio of R2 by R1 or R1 by R2 you calculate. What is the ratio of R1 by R2 you have to calculate. R1, R2 is not given. Okay. And VB, you can take VB is 0.7. VB is 0.7. So solve this one. So
Sir,
the
GCC value is not
idea is
given.
idea is that current in this circuit should be always greater than this IB. You can always, so by approximation method, you can always calculate the IC, and if you know you can do the back calculation, you can find the beta, and and you can find, and now you know this current. Okay, you can find the beta and you can compare the current with this one. If the current in this one is more than the IB, you can always neglect. Tell me, what is it? What is the question?
What is VCC value?
VCC value is 6 volt. VCC is 6 volt. So you can neglect this current IB only when current in here is very high compared to this one, at least 10 times of this current. You can neglect this current. So first approximate method, use approximate method. What you can find? VB will be what? VCC 6 upon R1 plus
Sir,
R2.
is it coming 4?
Yes, yes. So VB is 6 upon R1 plus R2 into R2. And now VB, how can you find? VB you can find VB is equal to VB is equal to VB minus VE. So VB is equal to VE plus VB. Now IC is given. IC is almost equal to RE. So you can find this VE. So VE is what? V is your IE that is IC RE, and IC is what? 1 milliampere is given. 1 milliampere is given, and this is your 0.15 kilo ohm. So this comes 0.5 volt. Okay. So this is 0.7. So 0.5 plus 0.7 is give you 1.2 volt. Okay. Now you can put here 1.2 kilo, 1.2 volts. Now you can solve this equation and you can find what is the value of R1, R2. So VB equals to, that is 6 upon R1 plus R2 into R2 equals to 1.2. That is 6 R2 is equal to 1.2 R1 plus 1.2 R2. This will go there. So 4.R2 is equal to 1.2 R1. So R1 by R2 will be 4.8 divided by 1.2, that is 4. Okay. Now let me solve. Now accurate method tomorrow we'll do, but let me do one more problem, which is also in your exam. So I'm erasing this one. This problem came in JAM. Now this is circuit is given, voltage divider RC here plus VCC and this is your register. Here you have RE R1 R2. Okay. R1 is 80 kilo ohm, R2 is 20 kilo ohm, and this is your 1 kilo ohm. Okay, beta is 50. Beta is 50. RC is 5 kilo ohm. Okay. Beta is 50 and RE is 1 kilo ohm, 80 and 20. So tell me how to do this problem. So now, so interesting problem is there. So now let me first give you the option. What is the problem? So problem VCC is given 20 volt. VCC is given 20 volt. Now it says when R2 is disconnected, when R2 is disconnected, okay, when R2 is disconnected, then what happens? Point A says VB and VC increases. VB and VC increases. Point B says both VB and VC decreases. Both VB and VC decreases. Okay. Option C says, okay, VB decreases, okay, but VC increases, and the option D says VB increases, but VC decreases, but VC decreases. Okay. Now let us solve this problem. Okay. Now without doing actually calculations, we can solve this problem, but we'll do both the ways. Now what is VB? This is your VB. And what is your VC? This is your VC. Okay. Now you can solve this by approximation method, but see, condition is not satisfied. You say, if you say here beta RE, so beta RE should be greater than 50 into 1 kilo ohm, 50 kilo ohm. And this is your, so 50 kilo ohm is of course greater than 2 kilo ohm. It's greater than 20 kilo ohm, but not 200 kilo ohm. Okay. So always for safety, we check. See, actually, if this voltage, this resistance is greater than this resistance, then obviously this current is greater than this IB. Okay. But if you do the calculation, answer will not come accurately. Values, some values will be change. Okay. But here we're not supposed to calculate the values. We only want qualitative description. So I can use approximation method. We'll solve this with accurate method also tomorrow. But today I'm solving with only approximation method. Okay. Now let us see what happens if I solve this method with the approximation method. And even approximation method, I'm not solving. I am solving this thing directly without doing any calculation. But you have to solve with calculations. Okay. So he says if this R2 is disconnected, when R2 is disconnected, what will happen here? This what happened to VB, what happened to this VC? Okay. Now you tell me what will happen if I remove the if I remove the R2, what will happen? So if I remove this R2, suppose here, okay, if I removing this R2 here, now tell me what is the VB will increase or decrease? Tell me, VB will increase or decrease?
सर VB इंक्रीज होगा ना सर?
कैसे? Tell me how?
सर ये ड्रॉप हो रहा था सर यहाँ पे, सर वहाँ तो ओपन हो गया ना.
हाँ, तो और anything, anybody else? Karishma, Leo. Now BP will increase or decrease? Tell me. So let us understand in this way. Okay, when this resistance is there, R2 is there, current flowing in neglect IB, because using forget IB. Current flowing here and here is in milliampere or microampere. R2 is 20 kilo ohm. So this is 80 plus 20, 100 kilo ohm. And this is VCC. What is the value of current? Tell me.
सर मिली एम्पियर में होगा ना?
So almost milliampere है. Okay. Miss milliampere में भी see इसलिए milliampere. So how much is 20 divided by 80 plus 20? How much? 20 divided by 100 kilo ohm. 100 kilo ohm. 100 na? 100 kilo ohm. So this is how much? Tell me what is the current? This is 0. This is 1.5, 0.2 milliamps. Okay, that is 200 microampere. Now suppose if I reduce this current, now suppose if I remove this one, okay. Now generally this IB is in microampere. This is also in microampere, but value may current value may decrease. So whatever drop happening here, will be now less. If this circuit is connected here, the current is here high. Okay, this current is here resistance are very high. Suppose this is only 10, then current is milliampere. Now if I remove this circuit, what will happen? If the circuit is there, then the drop is here more. So this voltage is decreasing. Now I remove this circuit. Now the current flowing, which is IB, and IB is generally very less because the voltage here is drop also, here also drop is there. So what will happen? Now your VB will decrease. VB will increase because the drop is less. And if VB increases, what will happen? Tell me. If VB increases, then what happened? This V also increases. V is what? V is your VB minus VBE. This is constant. So VB increases, your VE also increases. And now if VE increases, okay, V increases, so VE is basically your ICRE. Okay, if V increases, your IC also increases. And if IC increases, your VC is what? VCC minus ICRC. If IC increases, this drop increases here. If drop increases here, your VC decreases. Your VC decreases. So that means VB increases, but VC decreases. Option D should be the correct. Okay. What I'm saying, it is correct. If this you do calculation, if this satisfied, then this option is correct. Okay. Let us check this what happens, whether it is correct or not correct. Now your R2 is say 20 kilo ohm. Okay. Now only we are doing approximation method. Okay. So first understand this one. If I remove what I'm saying, if I remove this one, then what will become? If I remove this one, the current here will become decrease because current is going more here now. But if I when I decrease here, this current becomes IB, and IB is generally very small. So this drop decreases, so VB increases, VB increases, V increases, V increases, IC increases, IC increases, this drop increases, BCs go down. Okay, this is qualitatively. Now we will check actually what happens in reality by solving this one. So let us now solve. Find the VB neglecting IB, IB 0. Okay, find out what is happening of VB. So VBB is your VCC R1 plus R2 into R2. Okay, 20 upon 100 kilo ohm. R2 is how much? 20 kilo ohm. This 10 decreases. Okay, this goes down. So this is 40 upon 10. That is 4 volt. Check the calculation is correct or not. 4:1. 16 into 4. So your VB is 4 volt. Okay. And now tell me, if VB is 4 volt, this value, what is the value of, tell me, VE? V will be 4 minus 0.7. What is the value? 3.3 volt VE. Okay. Now, once you know the VE, you can find the IE. 3.3 volt divided by 1 kilo ohm. This comes out 3.3 milliampere. And I can take this is equal to IC. Okay. And once I know the IC value, I can find the VC. VC is your VCC minus ICRC. VCC is 20. IC is how much? 3.3 milliamp. RC is your 5 kilo ohm. This cancels out. 20 minus how much? 5. 16.5, and this comes out how much? 3.5 volt. Check this value whether correct or not.
Yes, sir, correct.
Correct. Okay. So note down here, VB is 4 volt. Okay. And your VC is 3.5 volt. Okay. Now remove this circuit. And let us again calculate whether what we are thinking is correct or not correct. Generally it is correct, but we don't know because here resistance values are very, very high. So it may not be correct. Okay. So we'll check now what is happening. 4 volt, 3.5 volt. Okay. Now solve this circuit. This value already you know. Now current is here is IB. So minus VCC. So IB. So now what will happen? Now it has become simple circuit. So IB will be what? IB will be VCC minus VBE plus RB plus beta plus 1 RE, because now circuit become like this. Feedback circuit. So what is IB? So IB will be VCC is your 20 minus 0.7. RB is 80 kilo ohm. Beta plus beta is 50, 51 into RE. RE is 1 kilo ohm. So check the values. What is coming? IB. So IB is your 19.3. This is RB is your 80 kilo ohm, and this is 50 beta plus 51 into 1 kilo ohm. How much is this? Tell me. 131 kilo ohm. So 19.3 131 into, tell me, milliampere. How much is coming?
0.148.
0.148 milliamps. Okay. Someone else also recheck this one. Now you can find the IC value. IC will be beta IB. Beta is how much? Beta is 50 into 0.148.
7.4.
7.4 milliampere, huh?
Yes, sir.
Milliamps. Find the IC saturation. Find the IC saturation. IC saturation. 20 upon RC plus RE, 6 kilo ohm. 6 kilo ohm.
3.33 milliampere.
3.33 milliampere. Okay.
Milliampere.
So this is, so my IC become what? Greater than IC saturation. Oh, that is interesting question. IC become greater than IC saturation. If this calculation is correct, please tell me this calculation is correct or not. I think this is not
Yes,
correct.
sir.
कैसे करेक्ट होगा? अगर ये 100 हो जाएगा तो कितना हो जाएगा? ये 100 हो जाएगा तो 0.1 7.4 correct. So the calculations, if the calculation correct, now my IC become greater than IC saturation. So now my value of IC is what? My value of IC become now what? Actually become this one, not this one. We cannot take this one. So this become actually this point. This current we have to take now. Oh, so this is a interesting question than what I was thinking. More interesting than what how I was thinking. Okay, so this become 3.3 milliampere. Okay, now what we'll do? Tell me. Now you can find what is VC. What is VC? So now VC will be what? Remember what is IB, and now calculate VC. So VC will be now VCE will be 0, okay? Because this coming saturation current. So I have to take VCE 0. VC 0 means VC minus VE is equal to 0. So VC equal to VE. So I will take VC equal to VE. Okay. So because this is going saturation VC is always 0. VC minus VE, VC equal to VE. Now what is the value of VC? Tell me. VE. What is the value of VE? IC into RE. IC into RE. Okay. So VCE is equal to VC minus V0. So VC equal to VE. That is IC into RE. And IC is what? IC is your 3.3 milliampere. RE will be what? Tell me. RE 1 kilo ohm. This cancels out. So VC become 3.3 volt. And earlier it was what? 3.5 volt. Now it is decreasing or increasing?
Decreasing.
Decreasing. Okay. Now you have IC value. This one IC value. Now you can do you can do the back calculation of IB. Because this is now you cannot take this IC value, na? So if you cannot take this IC value, then you cannot take this IB value also, because it's going in saturation. So now you take, what you'll do, you have IC value is this one, 3.3 milliampere. Then you calculate IB value. IB value will be IC by beta. Okay. Understand the question properly. So IB will be now, IC is 3.3 milliampere and divide by 50. Okay. Tell me how much is coming. IB value
0.067.
0.067
067.
milliamps. Correct. Three point 33 10 to the power 5, and then again 33. Okay, correct. Now this is your IB. Now you want to find the VB. Now you want to find the VB. So VB will be what? VCC minus IBRB. VCC is your 20 volt minus IB is your this one 0.067 into 10 raised to power minus 3 into RB is how much? 80 kilo ohm. This cancels out. Tell me what is the value of VB? So 20,
14.64.
14 point, solving total, huh?
Yes, sir.
14.664
64.
volts. Okay. So VB increasing or decreasing?
Increasing, sir.
Increasing. So VB increases, VC decreases. Okay. But you always try to solve and then tell, okay? Because I have some experience, so I can directly understand what is happening. But maybe I may also be wrong sometime because the resistance values are there. Okay. Here is clicking, so I told this will be happened. Okay. But you always calculate. This we have done what? This we have done with approximation method. Same question we will do tomorrow with a accurate analysis. We'll see whether this is true or not true. Okay. Sometime they purposefully put these questions, so there is some mistake is there. Generally we can do mistakes. Okay. Now because this condition is not satisfied, beta RE2 here. Tomorrow I will do the same question with the accurate method, and then we can reach conclusion what is actually is happening. Okay. So I'll stop here. Okay. Thank you.
Thank you, sir.
Thank you.